All right, sorry about the problems we had this morning with the meet. Hopefully things will go smoother on Tuesday. All right, so today we're still talking about quadratics. We will be converting them between standard and vertex form, and we will be talking about graphing them. Remember, standard form is the ax squared plus bx plus c. Vertex, you have positive or negative a times x minus h squared plus k. Okay? So we are also talking about giving these equation and area models. So below we have two area models. This was something that Autumn received at her quilt shop, and it just has the block pictured below. So we need to show two equivalent equations for the area of the block. So again, we're going to do it in standard form and in vertex form. Going off what we know on the quadratics and our areas, we started with x and then we extended it by 3 in each dimension. Okay, so I'm going to start by writing this in vertex form. I'll do that over here. So I know that I have x plus 3 is my area and I'm squaring it. Now I need to factor in that there is not just one block, there's actually 2 blocks. So it's 2 times that area. And then there's nothing else that goes on the end, right? So here's my 1. So here's my vertex form. That means that A is equal to 2, H is equal to 3, and K is equal to 0. This is slightly different than the vertex form because I am actually adding on, so that's why that comes down as 3, not as negative 3, right? Then the other form that it is asking us to look at is a second form of that, standard form, right? So to get standard form, you just multiply it all out. So I will write that on the other side. I have the 2. Inside, remember our format follows that you square the x. You do 2 times your b term, or I think we were calling it d term. So 2 times 3 is 6x plus our number in there squared, which is then 9. Then you multiply the 2 through, x squared plus 12x plus 18. Okay, here are our 2 equivalent equations for that. Now we're going to do one based on just words. We're looking at 2 blocks that the dimensions are increased on both sides by 1. So here we have x plus 1 squared. We are dealing with 2 of those blocks, and that's what our equation be there. All right, now Optima's dog Clementine has decided to chew up some of the orders, and we are missing this part right here of our equation. So now we need to figure out what we need to do to get in there. So now just take a minute and try to think, what do you think that you would do to try to figure that out? We've done this before. The difference being that last time we didn't have a coefficient there, right? It was just x. So we didn't have to worry about what was going on there. So how I'm going to go about this is I need to pull that 2 out in front. I don't want a 2 in front of my x squared. So basically I'm dividing everything in there by 2. So that's going to leave me with 4x. Well, to complete that 4x, this as a square, you would add 4 inside, correct? And then this converts to 2 times x plus 2 squared. Next, I have the 3 out front. I want to factor it out. I get x squared plus 8x. Well, 16 is going to complete that square for me. And then that's going to change into 3 times x plus 4 squared. Now we're just going to practice converting these in between standard form and vertex form. Remember, in vertex form, we do need to have that complete square. That's how we get it in a quantity. So I first look at this one. I notice here that 13 is not a complete square of something, which means I need to complete the square on that. To complete the square, we take b divided by 2. So 6 divided by 2 and square it. We add that on, but we will also subtract it off. Quantity squared. Inside here, I get x. 6 divided by 2 is 3, and 3 squared is 9. And then over here, I have 13 minus 9, which leaves you with 4. And that is our new equation there. B, 16 is a perfect square. If it matches, the square root of 16 is 4. 2 times 4 is 8. We're good to go. Notice it is minus, so it's x minus 4 squared. A of x equals that. And our next one, 3, that is not a square, a perfect square. So I need to figure out what goes on there. I'm going to do x squared minus 10x. My minus 3, I'm going to move over here. In the middle, I need to put my b, which is 10 divided by 2, and square it. And then I need to do that out here also. This here, this part becomes my perfect square. And I get x minus 5 squared. And then I get a negative 3 minus, because this is a negative, I'm sorry, not plussing. Right here I need to minus it. Remember, you plus it and minus it. Minus 25. And our final answer then is x minus 5 squared minus 28. Okay. Go ahead and give D and E a try on your own. The one that we do need to kind of look at is F here. Okay. F is a little bit different because when we pull out the 2, I'm not going to get an even number on the end, right? I'm going to get 11 divided by 2. I prefer to keep things in fractions. It's just easier to work with, and fractions are more accurate. I pull out the 2, you get x squared minus 11x plus 11 divided by 2. Okay, I need to complete the square though, right? So I'm going to go ahead and extend this out. To complete the square, I need to, one second, I'm actually going to move this. So this is our coefficient. I like to keep it over here because I know that I'm adding something in here to complete my square. Here I need to add b, which is 11 divided by 2, and square it. Then over here, I need to minus 11 divided by 2 squared. This part becomes my complete square of x minus 11 halves squared. And then I have this whole mess going on over here, right? So this is going to end up with, I'm going to move up top. I have 11 halves, which actually I'm going to put it on over 4, right? Because this is going to end up at 4. So the squared part of it moves up here. 11 squared is 121 over 4. I want to rewrite this in terms of 4, so I'm going to multiply top and bottom by 2. I get 22 over 2, or 22 over 4, sorry. This is positive, that's negative. So when you simplify them out, you get 121 minus 22 is 99. So then we have inside 99 over 4. My bad, that's a minus sign again. Keep getting my signs messed up, guys. And you're not here to call me out on my mistakes. Okay, remember we have to distribute the 2 through. 2 times x minus 11 halves squared. And then minus, when I multiply 2 by that quantity of 99 over 4, it simplifies into 99 over 2. And there is that. Okay. So in generalization, if you have this ax squared plus bx plus c, where a does not equal 0, factor out the a. So the term that we finished doing is really going to be b divided by a, then that divided by 2 and squared is what we're adding in to complete the square. But then don't forget that when we add that in, we minus that out, and you have the 2 on there also. So we factor it into something that looks like a times x squared plus b divided by a x plus c divided by a, right? Then you have to take the b divided by a divided by 2, square that whole thing, and plus and minus it on the end. Now let's start talking about the graphing. Jenny's niece is at the quilt shop and she is working on some of her homework, and she realizes that what she's been asked to graph her parabolas look a lot like these order forms they've been taking in. So if we look at this equation she's given here, y equals the quantity x minus 3 squared plus 4. What do I know about that? Well, I know that this parabola is shaped like this. It's opened up because the a is 1 and it is positive. I know that it has been shifted to the right by 3 units. And I also know that it has been shifted up by 4 units. Thank you to vertex form, right? We can just see all those as soon as we look at it. So now here she thinks she's figured out how to change from the quadratic equation so that she can graph the parabola easier. So the equation she's looking at now is x squared minus 6x plus 9. Do we have a perfect square? Yes, we do. 9, the cube root of 9, the square root of 9 is 3. 3 times 2 is 6, and the pattern holds. So this is equivalent to y equals x minus 3 squared. The vertex of the parabola is at 3, 0. And then we need to graph it with at least 3 accurate points. So I've already graphed it here. Our vertex is at 3, 0. Then I just start putting in numbers. I choose on either side, right? We need 3 on either side. So since we're starting at 3, that means I need 0, 1, 2, 4, 5, and 6 to graph. And then I just put it in to get my terms. That's basically the same as making a table, right? So you're just making your table of, hey, when I put in 0, I get out 9. When I put in 1, I will get 4. When I put in 3, I get, oh, I don't put in 3. Sorry, when I put in 2, I get 1. When I put in 3, I get 0. And then that pattern is going to hold on the other side, right? Because we start getting negatives inside our parentheses, but when it's squared, the negatives go away. So I get in 4, I get 1. When I put in 5, I get 4. And when I put in 6, I get 9. So there's my table with 3 points, because here's my vertex on either side of the vertex. A little thing that you need for the homework, it's going to ask you about identifying your intercepts. So your y-intercept is when x is equal to 0. Therefore, c is your intercept. When we're looking at ax squared plus bx plus c, when it's in this format, c is your x-intercept, right? Because this term and this term will go away. So that will help you match the equations in the homework to that. If you have any questions, please email me. Again, sorry about the problems this morning. Hopefully on Thursday, everything will be good to go.